over for me, flip over. We're now going to slightly change, but it's going to be pretty much the exact same idea. Once again, my y is my final amount. So you should be on the back side now. My y is my final amount. A is still my starting amount. All right. And my R is still my percentage as a decimal. Still my percentage as a decimal. All right. And T is still time. T is still time in years, most of the time in years. I'm going to leave that off because it doesn't necessarily have to be in years. Okay, so but here's the only difference. Everything stays the same. Y equals A times 1 and all R all raised to the T. So you can see everything's the same minus one change. Instead of it being a plus sign here, it's now a minus sign. And the reason why is because we are decaying. If this is decaying, then it's now going to be a minus sign instead of a plus sign. So lots of things decay in value. The value of your car or your mom and dad's car is decaying as we speak. The value of some commodities, some different things are decaying as we speak. So in this case, we have a tractor that we bought for $45,000. Well, when we bought it, that was our starting value. So our starting value is 45,000. Now, the tractor depreciates. You may have never heard that word before, but to depreciate, all right, to depreciate means that you are decaying in value. Depreciate is to decay. You're going to hear the word appreciate again as well. Appreciate is not like, oh, I really appreciate you, but it's appreciate in the context of the math is that you are increasing value. Depreciate, decrease. All right. Well, we are decreasing in value by what percentage? By 12% per year. So this is exactly the same as what we've already done. Y equals our starting amount, which was 45 grand. So 45,000, open parentheses, the one that's always there. Here's the only change. Instead of it being plus, it's now going to be minus, and we're going to be subtracting our rate. So 12%, don't forget 12% as a decimal is 0.12. Move that decimal point two places. So 0.12. Close the parentheses, and we raise it all to t. We don't know how many years it's been yet. All right. So now, honestly, we do know what's the value of your tractor after 5 years. So all you got to do is take that 5 and plug it in. So grab your calculators. All right. Grab your calculator and let's start plugging in. So I'm going to clear out what I've got. 45,000, open parentheses, 1 minus, instead of plus, 1 minus 0.12, close the parentheses, all raised to the fifth power. So take a second, type that in yourself. Type that in yourself. Get the practice of doing so. Hit enter, and here we go. Our tractor is now worth. It went from being $45,000 to now it's down to $23,000 and $23,747. So $23,747. So just make sure that was right. Yep. There you go. So we have depreciated. The value of our tractor has gone down a ton. So, guys, the rest of this is really just practicing more of the same. So, take a second, press pause, and try these two practice problems. Give them a go. They shouldn't be too challenging. Give it a shot. Okay, so hopefully you've pressed pause, you've done your problems. I'm just going to rock and roll real fast. 18,000 is my starting amount. 1 minus my value again is 0.12. My percentage there is 12%. And what's my time? It was 2009. Now it's 2015. That's been 6 years. Plug that in. Super, super easy. Okay. My second equation here, the population of Detroit, that is definitely, or at least it was dropping. So it used to be 1,849,568. It's decreasing. The population is decreasing. So we have 1 minus our rate. It's decreasing at a rate of 1.5%. So 1.5% is 0.015. So let's plug that in. Whoop, almost got a zero. 0.015. And now we raise it to our time. How many years has it been? Well, it was 1950. This is now 2009. That's 59 years. So there you go. That's all it is. All you got to do is plug those values into the calculator and you are golden. All right. So the last piece that we really want to focus on is this idea right here. So it's at the very bottom of your notes. It's kind of a challenging idea because we're trying to find not necessarily, well, what's it going to be after such and such amount of time, but we're trying to figure out what is the rate, all right, the rate, all right, to find the rate that an amount is growing or decaying. We really are trying to figure out how far away are we from 1. Okay, so for example, if we're growing at a rate of 12%, then we're 12% away from 1. And that's pretty easy, okay? But it's the decay one that's tough. So let's do the easy one first. We know that our function is this. So the first thing we have to do is we say, well, okay, what is my b value? Well, my b value is that 1.35, okay? So that's my b value. So here's what we've got to figure out. Well, if it's 1.35, that means that we are basically we're bigger than 1, right? Obviously, doesn't take a genius to figure that out. So if you're bigger than 1, then here's what we're going to do. We're going to take that number, 1.35, and we're going to subtract 1 from it. Okay? So if we subtract the 1 from it, we're left with 0.35. Well, look at that. That right there is your percentage. So what does that equal? That equals 35%. So this is kind of backwards. They're not giving you the percentage this time. This time they're giving you the B, and you got to figure out what the percentage is. So our rate of growth is 35%. So that's really not very hard at all when it's growth. When it gets tricky is when it's a decay problem. When it gets tricky is when it's a decay problem. So when it's a decay problem, let's take a look at this one. Our function here is y equals 3 times 0.72 raised to the t power. So hopefully you're already going, okay, b is 0.72. Well, if b is 0.72, that's less than 1, so we know that this has to be decay. So if that's going to be decay, here's what's happening. We are smaller, right? Smaller than 1. So if we're smaller than 1, it's going to slightly change how we do the problem. Instead of doing our b value minus 1 like we did right here, okay, we did our b value minus 1. Now we're going to do the reverse. We're going to do 1 minus the b value. Well, we know our b value. Our b value was 0.72. All right. So we have to do 1 minus the b value. And what are we left with there? If we do that, we're left with 0.28. 0.28. So that 0.28 means that we are decaying at a rate of 28%. All right, so very important that you can understand the difference between those two components, that you really want to make sure you can identify the rate of growth or the rate of decay. And that depends entirely on how you do this. So 1.35 minus 1 if it's growth. In this case, it was 1 minus 0.72. All right, you're going to have another practice problem and keep working hard.